So let's start with our first question. He's saying a sprint walker completes a 200-meter reach in 40 seconds. What is the average speed during the race? So here we are asking for the average speed. How to calculate the average speed? We have a formula for this. Average speed is equals to total distance divided by time taken. So distance that he traveled divided by the time. So here, how much of the distance he traveled? It's 200 meters. So we can say 200 meters divided by the time it took him to cover this distance, which is 40 seconds. So 200 divided by 40 seconds. So 200 meters divided by 40 seconds. The answer would be 5 meters. So you find the answer would be A. And would you ask yourself why it's written as meter second to the power of -1? It's same. Meter per second is exactly the same as meter seconds power of -1. We send the seconds to the upper part. So once we send it to here, we have 1. So once we send it to the numerator, it would be meter seconds to the power of -1. So this is the answer for our first question. Second one. So in this one, he's asking about a car accelerate from rest to a speed of 40 meters per second in 5 seconds. What is the car's acceleration? So here we are asking about acceleration. We have a formula for acceleration also. Acceleration equals to what? Change in velocity divided by the change in time that we have. So V final minus V initial divided by T final minus T initial. And here he is saying that a car accelerated at a speed of 40 meter per second to a speed of 40 meter per second. So we can see here V final minus V initial divided by T, or T final minus T initial is going to be the same since our T initial is 0. So we can say divided by T directly. So let's see, our T final is 40. So it would be 40 minus, what is the V initial? It's accelerate from rest. So the initial velocity is 0. So 40 minus 0 divided by time, which is 5 seconds, the final time he reached. And of course, we are starting from 0. So it's 40. This one will be cancelled with this one. So it's going to be 40 divided by 5. And the answer would be 8. What is the unit of acceleration? Let's see. The unit of velocity is meter per second. And the unit of time is seconds. So meter per second. So it would be meter per second squared. Also, if we send it to the numerator, it would be meter second to the power of -2. So the answer would be B, 8 meter per second squared, or meter second to the power of -2. It would be exactly the same. Question 3 is saying, what is the definition of acceleration? Let's see from the formula. Acceleration is equals to change in velocity divided by change in time, right? So V final minus V initial divided by T final minus T initial. Let's see the definition that we have on the question, the choices. So first one, he's saying the length between 2 points. Okay, no, it's not the length between 2 points, so the first one is wrong. The length between 2 points in a certain direction. Also, no, it's not like this. So the rate of change of the displacement. Rate of a change of displacement is the wrong one. So last one, he is saying the rate of a change of velocity. Yeah, here's it. Rate of a change of velocity. So the answer would be D. And if you need to know what is the first ones, for example, the length between 2 points, this is distance. This is not the acceleration. Second one, the length between 2 points in a certain direction. In a certain direction means displacement. Third one, a rate of change of the displacement. Rate of change of displacement is velocity, because velocity equals to change in displacement divided by change in time. So this can be considered as velocity. So first one is distance, displacement, velocity. Rate of change of velocity would be acceleration. So the answer would be D. So in this one is saying a velocity time graph. So we have a velocity right there and we have a time one. So a velocity time graph shown for an object, which statement describes the object motion between X and Y correctly. So X and Y, here is it. It's right there. So first one is saying constant acceleration. So constant acceleration, no. Why? Because if you have a constant acceleration, it's acceleration, so the velocity is always increasing. What is acceleration? We have 5, 10, 15, since it's constant, 20, it's increasing by 5. So it's always the velocity we're going to increase. So the constant acceleration graph would be this one. Okay, constant acceleration. This one is the graph for a constant acceleration. What about increasing in the acceleration? It would be a curve right there going upward like this. And of course, the last one, decreasing the velocity would be in the other hand. So probably it's not the constant acceleration, no, because here is it, the graph of it. And it's also not an increasing acceleration. Here is it, increasing acceleration. What is the right answer? Yeah, between x and y, here we have a constant velocity. For example, here we are going to have 0 right there. Wait, here we having 0, and here we have 5, for example. So yeah, as you can see, it's moving in a constant line right there. So this can be considered as a constant velocity. Okay, so x and y it would be constant velocity. Let's see the last one, decreasing velocity. No, decreasing velocity, it would be, for example, we have 0, 5, 10, and here's the time one. So decreasing by time, so it's 10. So after that, it would be 5. After that, it would be 0. So the graph would be like this. This is for the decreasing velocity. So constant acceleration right there, increasing acceleration right there, decreasing velocity. So the only one that can be a right answer for question 4 would be constant velocity for x and y. Question 5, he's saying a velocity time graph for an object shown. Here is it. Which property of the graph represent the total displacement of an object? Total displacement. First one is saying the gradient of the line, total between the total area between the line and the x-axis, and the axis anyway. The y-intercept, the x-intercept. Probably it's not y-intercept or x-intercept, so this one is not important for me. Here we have the gradient of the line and the total area between the lines. Okay, so here, as you can see, this is a positive displacement. Why? Because we know that velocity is equals to displacement divided by time. So when we multiply both of them, we are getting what? We are getting displacement. So displacement equals to velocity multiplies by time. So this two will give me a displacement right there. So what it would be, the area under the curve would give me the displacement. Here we have area 1, which is a positive displacement, and area 2, we have a negative displacement. So it cannot be the gradient. It would be the total area between the line of the axis would be the displacement of this one, the represent of the displacement in this graph. Okay, so the answer would be B.